Hypothalamus artificial intelligence. Presence. As an expert system in optimization modeling, OPTEX incorporates its own mechanisms to store the experience. This is called artificial hippocampus. Mathematical intelligence underpins the mathematical models that some humans develop to make their decisions. Second, mathematical model is a scientific representation which make use of mathematical language to describe or to explain the portion of reality that is of particular interest to an individual. It is the result of the research carried out by certain humans. The mathematical models are growing as analytical tools that provide greater processing speed to the investigation. For its understanding requires formal training in mathematics and in the science being modeled. These models increase the intelligence of human beings, creating large differences, chasms, between them. When intelligence works under this model, we will call it mathematical intelligence. This ability to understand mathematics, and to handle it, does not extend to all humans. It is necessary to acquire knowledge and experience, to handle this intelligence properly. At present, its development is directly related to the ability to handle computational and mathematical technologies. Mathematical intelligence and decision-making. Decision-making process is the final objective of any person or organization, which seeks to make the best decisions from its point of view, its criterion. This process, when carried out in real time, requires a great capacity for mathematical calculation, to handle the complexity of the real world, which increases over time, since the universe increases its entropy at each moment. When humanity began its evolution, it only had mental models to support its decisions, which seriously limited the speed of the evolution of the species, due to the little, almost zero, capacity of mental models, which led the human being to make decisions with very few calculations, or without them. Thanks to analytical intelligence, human beings developed their mathematical intelligence, which has led us to Industry 4.0. Since the creation of AI, and the advent of the computer, it can be said that predictive methodologies displaced prescriptive ones, in what was called artificial intelligence. For the convenience of the reader, decision-making artificial intelligence, DMAI, will be presented in comparison to traditional artificial intelligence. The first big difference is that DMAI is based on the study of mathematical intelligence, which focuses on the representation of the physical world through algebraic formulas, or through differential calculus, and solves problems using exact mathematical algorithms, aimed at finding the best decisions. This area of science corresponds to prescriptive analytics. The displaced methodology is formal mathematical modeling using algebraic equations, and/or differential equations. This is related to the use of mathematical programming, or optimization, to support decision-making. It is easy to show that in most companies, mathematical programming is not considered to produce knowledge, like the human. This is because decision-making does not concern researchers who promote artificial intelligence. Practitioners, perhaps fanatics, of traditional AI, have classified mathematical programming algorithms as the exact methods, not with the intention of highlighting them, and promoting their learning. On the contrary, they disqualify them because in theory they cannot be used. But this is false. The essence of mathematical intelligence modeling is based on the study of the human brain, based on neuroscientific studies. The result is the production of artificial brains. The creator of the human brain conceived it as the integration of three main organs, or systems: neocortex, hypothalamus and hippocampus. The hypothalamus is part of the thalamus. The artificial brains corresponds to the scientific foundations, more specifically mathematical fundamentals, that allow to connect multiple mathematical models, algorithms or robots, exchanging information between them to obtain a common goal, and act as holistic intelligence of the organizations, or parts therein. Like the human brain, the artificial brain is composed of the following artificial components: neocortex, hypothalamus, and hippocampus. Emphasizing that Hai is not an expert in neuroscience, its interpretation of the functioning of the brain is presented. The cerebral cortex stores all the connectivity of the neural networks that make up the brain. The hypothalamus is the organ that ensures the proper functioning of the human being. The connectivity of neurons in the cortex determines how the hypothalamus should function. The hippocampus is responsible for managing memory, which interacts with the hypothalamus, to determine the actions that the human being will perform, that is, decisions. Artificial entrepreneurial brains are based on these hypotheses. Artificial hippocampus, a mathematical models expert systems. The hippocampus. Storage structures and processes from the decision-making that must be faced permanently. The artificial hippocampus is based on the mathematical synthesis of the information generated by algorithms and problem-solving processes, to use it in new runs of these algorithms to speed up the problem solution in real time. Artificial hippocampus store, like in the humans, the experience, and the knowledge acquired over time. Mathematical modeling expert systems. A knowledge-based system, KBS, must store two types of knowledge. Mathematical components, equations, problems, models, previously used and working properly. This information is generated by the modeler who builds the mathematical models and their entire operating environment, and results of previous runs to speed up the solution of new problems. This information is generated by the math models when they are used, and correspond to the trajectories of the variables involved in these models. The use of this information is totally dynamic, since it depends on the value of the input parameters in each new run. The learning process of the human being is concretized in memory, which accumulates information to face each new situation using all the knowledge that has been made up to that moment. It could be said that, to support decision-making, the artificial hippocampus stores historical information related to the models formulated and that work correctly, and the runs made with a certain model, in such a way to be able to use this information in new runs. The first case has already been analyzed throughout this presentation. Artificial hippocampus. Storing the history of runs. While mathematical models on digital computers, and the data storage disks, date back many years, more than 60 years, and despite the Industrial Revolution 4.0, how to run a model, it does not seem to have evolved. The normal process is: the model is thinking monolithically. A high-performance solver is selected to solve the problem, and the results are post-processed, and the results of the models are stored, with administrative purposes. Usually, in the next run, the model starts from scratch, ignoring the past, that is, it has no memory. In some cases, it is heated from a starting point provided by the last run, presumably the last optimal solution, or a point that ensures feasibility. However, an artificial hippocampus, designed for the artificial brain, can take advantage of a lot of information produced within a run, and during the history of all runs. Two examples will be briefly presented. Handling of Bender's theory, and generation of convex hull. For example, a basic artificial hippocampus can be constructed using Bender's partition theory, which can be interpreted as: the general problem is divided into two complementary subproblems, an experimenter, that makes decisions in real, or in simulated, environments, and that send the results to the higher level, and an information manager, that stores the results, sent as primal and dual variables. When it is required to make a real decision, or to perform an experiment, the information manager processes the stored data to determine two zones with respect to decisions, a desirable zone and a non-desirable, or utopian, zone. Mathematically, this is done by generating cutting planes and incorporating them as part of the information to be processed. The experimenter receives the information from the manager, makes decisions, and sends the results to the manager. The speed with which this loop is made can be that of an algorithm, that does not stop until it finds the optimal solution, or that of a human who makes decisions step by step. The first non-optimal zone that contain values of the decision variables, that must be discarded because they cannot be optimum. From a human point of view, it contains decisions that should not be taken because there are better. The second non-feasible zone, that contains values of the decision variables, that must be discarded because they cannot be feasible. From a human point of view, it contains decisions that cannot be taken because they are impossible. Decisions not included in the two zones determine the area of rationally desirable and possible decisions. Following the principles developed by Benders, it is possible to build an artificial hippocampus that remain active and useful beyond the duration of a run of a computer model. To do this, the cuts generated in each run must be stored in such a way as that they may be used later. This implies a coordination work, since it cannot be guaranteed that the information as it is produced can be reprocessed later. OPTEX, as an expert system, stores the cuts of one run to be used in the next, which will produce new cuts. HY is researching in the creation of methodologies to generate new rules that fit the dynamic variation of the parameters that affect the models. While all the mathematical support is solid, there is no theory that can indicate which cutting planes should be selected when restarting the model. Problem that becomes big when the size of the database grows. For this reason, it is considered necessary to develop tools based on traditional artificial intelligence, artificial neural nets, to help the management of the hippocampus database. The idea is that for very large problems, the selection process will include an ANN. This is one of HY's research projects. Another alternative to generate knowledge that is stored in the artificial hippocampus is the generation of convex hulls associated with optimal solutions of the mathematical problems. The multidimensional grid that represent the convex hull can be incorporated into the integrated problems to accelerate the solution process. Depending on the specific problem, the convex hulls may be permanent, or they must be recalculated dynamically when the parameters of the mathematical models change. Convex hulls allow flexible approaches, as in the case of an energy transmission system, in which they can be associated to two different ways to solve the problem flow AC and DC flow. The production of convex hull of optimal points is a standalone process, therefore they can be generated outside the optimization process. Like Herbert Simon, Hypothalamus AI believes that the computer-based mathematical modeling is the greatest invention of all times. Thank you for your attention.